Welcome to the session on Lagrange's interpolation formula for unequal intervals. In the previous sessions, we discussed interpolation formulae, namely Newton's forward interpolation formula, Newton's backward interpolation formula, and Newton's divided interpolation formula. Here, we shall discuss the Lagrange's interpolation formula for unequal intervals. If y naught, y1, y2, etc., yn are n plus 1 values of a function y equal to f of x corresponding to n plus 1 arguments x naught, x1, etc., xn, which are not necessarily equally spaced, then the Lagrange's interpolation formula is y is equal to x minus x1 into x minus x2 into etc. into x minus xn all divided by x naught minus x1 into x naught minus x2 into etc. x naught minus xn into y naught. This is the first term, plus the second term is x minus x naught into x minus x2 into etc. x minus xn all divided by x1 minus x naught into x1 minus x2 into etc. into x1 minus xn into y1 plus etc. plus the n plus 1th term is x minus x naught into x minus x1 into x minus x2 into etc. into x minus xn minus 1 divided by xn minus x naught into xn minus x1 into xn minus x2 into etc. into xn minus xn minus 1 into yn. This is the Lagrange's interpolation formula. We have to derive this formula. Since n plus 1 values of y equal to f of x are given, we can approximate the corresponding polynomial function f of x as a polynomial in x of the nth degree. That is, we can write f of x as f of x is equal to, that is, y is equal to a naught into x minus x1 into x minus x2 into etc. into x minus xn plus a1 into x minus x naught into x minus x2 into etc. into x minus xn plus etc. plus an in general ai into x minus x1 into x minus x2 into etc. x minus xi minus 1 into x minus xi plus 1 into etc. x minus xn plus etc. The last term is an into x minus x1 into x minus x2 into etc. x minus xn minus 1. Here n plus 1 points are given, therefore, we can write the function like this. This is satisfied for the pairs x naught y naught, x1 y1, etc. xn yn. Now, we substitute first pair, that is for x equal to x naught and y equal to y naught, we make the substitution, then we will get the constant a naught, that is y naught is equal to a naught into x naught minus x1 plus x naught minus x2 plus etc. plus x naught minus xn, and all the other terms will become 0. This gives a naught is equal to 1 by x naught minus x1 into x naught minus x2 into etc. x naught minus xn into y naught. This is the value of coefficient a naught. Now, we substitute x1 y1, we will get this equation becomes y1 is equal to a naught into a1 into x1 minus x naught. This term will become 0, because if we put x equal to x1 here, this will become 0. Second term is a1 into x1 minus x naught into x1 minus x2 into etc. into x1 minus xn, and the other terms will become 0, because all the terms contains x minus x1, this factor is contained, therefore, all the other terms will become 0. This gives a1 is equal to 1 by x1 minus x naught into x1 minus x2 into etc. x1 minus xn into y1. This is the value of the second coefficient a1. If we substitute x2 y2, we will get this equation becomes y2 is equal to, here x minus x2 is contained, therefore, this term will become 0. Here also x minus x2 is contained. The next term is a2 into x2 minus x1 into x2 minus x2 minus x naught into x2 minus x1 into x2 minus x3 etc. All the other terms will become 0, therefore, y2 is equal to this. This gives a2 is equal to 1 divided by x2 minus x naught into x2 minus x1 into x2 minus x3 into etc. into x2 minus xn, here up to x2 minus xn. Therefore, a2 is equal to 1 divided by this, which gives that is a2 is this into y2. Proceeding like this, we will get all the coefficients. Therefore, this expression for f of x will become f of x is equal to, that is y is equal to, this is equal to a naught is 1 by x naught minus x1 into x naught minus x2 into etc. x naught minus xn into this x minus x1 into x minus x2 into etc. x minus xn plus into y naught plus a1 is 1 by x1 minus x naught into x1 minus x2 into etc. x1 minus xn into this product, that is x minus x naught into x minus x2 into etc. x minus xn into y1 plus etc. The last term will become x minus x naught into, that is the value of n is x minus x naught into x minus x1 into etc. x minus xn minus 1 divided by xn minus x naught into xn minus x1 into etc. xn minus xn minus 1 into yn. Here the value of n is 1 by xn minus x naught into xn minus x1 into etc. into xn minus 1 into yn, which will obtain if we substitute xn yn in this expression. Therefore, this is the Lagrange's formula. Now, we have to work out an example. Determine f of 40 from the following data. The values of x are given 30, 35, 45 and 55, and the corresponding values of y are 148, 96, 68 and 34. Here the arguments are not equally spaced. Therefore, we can use the Lagrange's interpolation formula. Take x naught as 30, x1 is 35, x2 is 45 and x3 is 55. The corresponding values of y are y naught equal to 148, y1 is 96, y2 is 68 and y3 is 34. We have the Lagrange's formula y is equal to, y means f of x, which is equal to x minus x1 into x minus x2 into x minus x3 divided by x naught minus x1 into x naught minus x2 into x naught minus x3 into y naught plus second term is x minus x naught into x minus x2 into x minus x3 divided by x1 minus x naught into x1 minus x2 into x1 minus x3 into y1 plus the third term is x minus x naught into x minus x1 into x minus x2 divided by x2 minus x1 into x2 minus x naught into x2 minus x1 into x2 minus x3. Which is equal to x minus x1 is here x1 is 35, x minus 35 into x minus x2 is 45, that is x minus 45 into x minus 55 divided by x naught minus x1, that is 30 minus 35 into x naught minus x2, 30 minus 45 into 30 minus 55 into y naught is here 148 plus x minus x naught, that is x minus 35 into x minus x2, x minus x2 is x2 is 45, x minus 45 here x minus x naught is 30, this is 30, x minus 30 into x minus 45 into x minus x3, x3 is 55 divided by x1 minus x naught, that is 35 minus 30 into x1 minus x2, x1 minus x2 means 35 minus 45 into x1 minus x3 is 35 minus 55 into y1, y1 is 96 plus this time is x minus x naught, that is x minus 30 into x minus 35 into x minus x2 is 45 divided by x2 minus x naught, that is 45 minus 30 into 45 minus next term is x2 minus x1, that is 35. 45 minus x1 is 35 into 45 minus x2 minus x3, that is 45 minus 55 into here y2. Y2 is 68. On simplification, we will get as the required value is f of 40. We put x equal to 40 in this, we get f of 40 as y means f of x. Therefore, if we substitute x equal to 40, this will become 40 minus 35 into 40 minus 45 into 40 minus 55 divided by 30 minus 35 is minus 5 into this is minus 15 into 30 minus 55 is minus 25 plus into 148 plus the next term is 40 minus 30 into 40 minus 45 into 40 minus 55 divided by here 35 minus 30 is 5 into 35 minus 45 is minus 10 into 35 minus 55 is minus 20 into 96 plus this term is 40 minus 30 into 40 minus 35 into 40 minus 45 divided by 45 minus 30 is 15 into 45 minus 35 is 10 into this is minus 10 into 68. One simplification, we will get this as 74.7, that is f of 40 is 74.7. In the Lagrange's interpolation formula we just derived, we have treated y as the dependent variable that was expressed as a function of the independent variable x. If we treat x as a function of y, then Lagrange's interpolation formula can written as x is equal to y minus y1 into y minus y2 into etc. y minus yn divided by y naught minus y1 into y naught minus y2 into etc. y naught minus yn into x naught plus y minus y naught into y minus y2 into etc. into y minus yn divided by y1 minus y naught into y1 minus y2 into etc. y1 minus yn into x1 plus etc. y minus y naught into y minus y1 into y minus y2 into etc. into y minus yn minus 1 divided by yn minus y naught into yn minus y1 into yn minus y2 into etc. yn minus yn minus 1 into xn. This expression is known as the Lagrange's inverse interpolation formula. Inverse inverse interpolation formula, Lagrange's inverse interpolation formula. Now, we have to express the Lagrange's interpolation formula in an alternative form, that is we have the Lagrange's interpolation formula y is equal to x minus x naught into x minus x1 into etc. x minus xn divided by x naught minus x1 into x naught minus x2 into etc. x naught minus xn into y naught plus x minus x1 into x minus x2 into etc. Sorry, here x minus x1 into x minus x2 into etc. x minus xn. This in the second term x minus x naught into x minus x2 into etc. x minus xn divided by x1 minus x naught into x1 minus x2 into etc. x1 minus xn into y1 plus etc. plus x minus x naught into x minus x1 into etc. x minus xn minus 1 divided by xn minus x naught into xn minus x1 into etc. xn minus xn minus 1 into yn. If we divide this formula by x minus x naught into x minus x1 into etc. x minus xn, we get y divided by x minus x naught into x minus x1 into etc. x minus xn is equal to, here if we divide by this term, x minus x1 into x minus x2 into etc. up to x minus xn will be cancelled. The remaining term is in the numerator y naught divided by x naught minus x1 into x naught minus x2 into etc. x naught minus xn into 1 by x minus x naught. In the second term, we get plus y1 divided by x1 minus x naught into x1 minus x2 into etc. into x1 minus xn into 1 divided by x minus x1 here plus etc. plus yn divided by xn minus x naught into xn minus x1 into etc. xn minus xn minus 1 into 1 divided by x minus xn. If we divide on the both sides by this product, we will get like this. This is another an alternative formula for Lagrange's interpolation formula. We can use this formula also. Let me conclude this session. In this session, we derived the Lagrange's interpolation formula and we observed two alternative forms of the Lagrange's interpolation formula. The Lagrange's interpolation formula is used to interpolate if the arguments are not equally spaced. This is a general interpolation formula. Thank you for watching this session. Have a nice day.